All right, this first lesson in the next unit, we're still dealing with quadratics, but this time we're going to be solving a lot of quadratics that are prime. So we're going to solve quadratics using the quadratic formula. So in the past, if I said solve f of x equals x squared minus 12x plus 8, we would label a, b, and c and then we would fill in the star. And I would say, okay, find two numbers that multiply to 8 but add to negative 12. And by looking at our list, we would say, well, 1 and 8 don't add to 12, and 2 and 4 can't add to 12. So we would just say, okay, well, this guy's prime. Well, today what we're going to figure out is there's actually a way to solve and find our x-intercepts or solutions or roots or zeros for this function. And using that, and the way we do that is we use the quadratic formula. So on the left side there, you see that for quadratics that would have been prime, we now use a quadratic formula. And yes, you do need to memorize this. This will not be given to you on the test, so each day you need to kind of like be going over this and making sure that you have this pretty much memorized. So it's x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Some teachers have come up with like songs to remember this. There is a song by the tune of Pop Goes the Weasel that I'm sure you could find on YouTube. If you think singing it or having a song for this might help you memorize it, I would highly suggest using that then. As you notice, in this equation, there is a square root. So what we're going to do before we even use the quadratic formula is we're going to review how to simplify square roots. So I gave you a list of all of our perfect squares up here, and these numbers are going to be extremely important of simplifying square roots. So what I'm going to do is I'm going to take the number inside the square root and I'm going to see if any of my perfect squares go into it. As you notice here, 64 is a perfect square because I know that 8 times 8. So since I have a pair of 8s, the square root of 64 is just 8. So the idea is finding a pair that you can pull out. Like I've taught this in the past, it's the buddy system. If you have a buddy, you're allowed to go outside. So for 50, I'm going to look on my list of perfect squares, and 50 is not one of my perfect squares. So I'm going to try and find a perfect square that does go into 50. So I'll just start at 49. 49 does not evenly divide 50. 36 does not go into 50, but 25 does. I know that 25 times 2 is 50. The reason this helps me is because 25 is a perfect square, which is 5 times 5. So that's where I get my partners that go outside. And now since this 2 does not have a partner, does not have a buddy, it cannot go outside, so he has to stay inside. So I pull the 5 outside, and then the 2 stays inside. And this is how you simplify your non-perfect square roots. So same thing with 72. I need to look in 72 to find a perfect square that will divide into it. Since 72 isn't on my list, I'm going to start with the next number smaller than it. 64 does not go into 72, 49 does not go into 72, but 36 does. So again, this is 36 times 2 is 72. And then my partners that multiply to 36 are 6 and 6. So I circle my buddies because they get to go outside, and then the loner of 2 has to stay inside. So again, this is going to be important when we look at this part of our quadratic formula. We are going to have to simplify roots inside our equation. So for the quadratic formula, I went ahead and wrote it up here so you guys can reference back to it. This is the same one that we already knew was prime. So again, I label A, B, and C. And then from here, I'm just going to plug that all into the equation. So I have x equals the opposite of b, so that's a positive 12, plus or minus the square root of negative 12 squared minus 4 times 1 times 8. And I put that all over 2 times 1. On the next slide, I'm going to kind of show you a breakdown of the best way to simplify these. So the first thing I'm going to do is take care of all of that multiplication underneath my quadratic. So negative 12 squared is 141 or 144, and 4 times 1 times 8 is 32, and 2 times 1 is 2. 144 minus 32 is 112. From here, I need to simplify my square root. I can't divide anything yet because what's inside the square root is kind of like stuck. You can't do anything with what's inside there. So we're going to use what we just saw on the last page, and I'm going to try and simplify the square root of 112. So when I go through my list of perfect squares, I know that 16 is the first number that divides 112, and it's 16 times 7. So 16 breaks down to my pair of 4s. So I know that will go on the outside, and the loner 7 stays inside. So I still have x equals 12 plus or minus 4 square root of 7 all over 2. And then the last thing I look at, and I would just call this like the triangle, so I can only look at 4, 12, and 2. If there's a number that goes into all three of those numbers, I can actually divide that out. So 12, 4, and 2 all have 2 in common, which will leave me with 6 plus or minus 2 square root of 7. And that's my final answer. So again, these are the steps of how to best go about simplifying your quadratic formula. The first thing you want to do is simplify underneath the root first. So take b squared, and then take 4 times a times c, and then subtract those two numbers. Once you have that done, you need to simplify the actual root. So again, seeing if you can pull a perfect square out. And then the last thing you do, and this is an if and only if, the first number, the number pulled outside the root, and the number in the denominator have a GCF, then you can divide that out of every single piece. So take a second to pause this and write down these steps. So my last example is just the same thing, except now the a value is not 1. So I'm going to follow the exact same steps. Label a, b, and c, and then plug everything into the equation. So this is going to be positive 13 plus or minus the square root of 13 squared minus 4 times 2 times 4 all over 2 times 2. So again, step 1 is simplify everything underneath the square root. So if I just plug this into the calculator, I am left with 13 plus or minus the square root of 137 all over 4. Now this time when going through my list of perfect squares and dividing 137 by each of my perfect squares, I noticed that none of my perfect squares go into 137. If that happens, this is actually the best thing because there's nothing that we can do. I can only divide that 4 out if the number in front, the number pulled out of the square root, and the number on bottom all have something in common. Well, if you can't pull anything out of the square root, then you cannot divide. So if there's no perfect square, then your problem is as simple as it can go. So your try and your own problem is solve the following quadratic using the quadratic formula. And you have x squared plus 6x plus 2. Good luck.